Hi, I'm Mrs. Burns and welcome to lesson 5.3 on organic compounds. This is the last lecture of chapter 5. So, what are organic compounds? Here is a picture of one way to represent an organic compound, and organic compounds will always contain carbon. So these black circles, or the dark ones on your papers, these are all carbon molecules here, or carbon atoms there in that molecule. They also usually contain hydrogen as well. So these white little circles are all hydrogens here. Organic compounds are really important in our world because all living things have organic compounds, including us. Organic comes from the word organisms, which means living. So we're talking about organic today, but there's also inorganic compounds. And they're the opposite. They are not living, so they typically do not contain carbon. Sometimes, though, there are exceptions, and they're found in non-living materials. So we can show organic compounds in a few different pictorial ways. One of them are structural formulas or stick formulas, and that's here, the first one. Ball and stick model, that's this one, or space filling model. So we'll talk about all of these with our example of methane. Methane is CH4, we learned in chapter 4. So CH4 can be drawn with our C in the middle and then 4 H's around. If you wanted to get really fancy, you could show the H's like so. And this larger triangle, this just shows that H is popping out at you, and the little dots or the slashes show that the H is kind of going backwards into the page. So that shows how the 4 hydrogens spread themselves out, as we see here in our ball and stick model. We can play with these ball and stick models by actually taking, you could use Play-Doh, or you could use marshmallows, or you could use molecular models to show how the carbon is in the middle and then the way that the hydrogens will space themselves around. Finally, a space filling. All this space here that I'm coloring in purple is filled up with this diagram of the space filling model. So it shows how much space they actually do take up. So what do we know about carbon? Do you remember things about carbon? It is part of group 14 on the periodic table, and it has 4 electrons in its valence shell. It likes to form 4 covalent bonds. It likes to form bonds with itself, other carbons. It likes to form bonds with things like hydrogen, nitrogen, oxygen, sulfur, phosphorus, and halogen elements. It can make things like chains. So here we would have a linear straight line chain. Carbon here is binding with a hydrogen on its left, another carbon on its right, and an oxygen on that right. Here we see the carbons make a big circle. This is called a ring structure. So these C's have a single bond here or a double bond with the other C. Also, they have hydrogens sticking out on the whole outsides. This can be represented like so. So when you get to drawing them a lot, you don't even need to write the letters. You just know that there are C's here and that all those extra bonds would be hydrogen bonds. Or you can get really complicated cage-like structures or different like webs of all of these different carbons all attached to each other here. Notice how the organic compounds are written with the carbon first. They are not an acid, so we do not write the H first. For example, methane is CH4. For the acids, we would have done this H first, but that's incorrect. We have to make sure that our C is first for our organic compounds, because acids are inorganic. So there are a couple types of organic compounds we're going to look at today. Hydrocarbons are the first one. They are organic compounds that only contain carbon and oxygen in a variety of different ratios. So the longer the chain is, the more easily it becomes a liquid. So we already looked at CH4, but let's try C2, and then we have 6 H's. 1, 2, 3, 4, 5, 6. Let's try C4, 1, 2, 3, 4, with 10 H's. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these are just different hydrocarbon chains. As you can see here, this one is longer than this one. So C4H10 would be more easily becoming a liquid. So just like how when we named in chapter 4 our covalent molecules or our compounds, the little subscripts here tell us just how many of that element there are in our molecule. So it says C4, so we draw 4 C's. It says H10, so we draw 10 H's. There are also alcohols as organic compounds. They contain carbon, hydrogen, and oxygen. Now I just noticed this O up here, this should be a hydrogen. Did I say hydrogen? I don't even remember. Okay, so this is carbon and a hydrocarbon and hydrogen. Hydrocarbon. Hydro meaning hydrogen, carbon meaning carbon, so this makes sense. It should be C and an H. Oops, sorry about that, you guys. Alcohol then has carbon, hydrogen, and oxygen as well. So there are 3 kinds that we're going to look at today. The first one is methanol. And the formula for methanol is CH4O. So we would have a C, an O, and 4 H's. And it would look like that. Methanol is poisonous to humans, so do not consume it. It's often used as a solvent for substances that don't like to dissolve in water. There's also ethanol. This is consumable by humans, and it's often used in alcoholic drinks like wine, beer, and things like that. But remember, it's only safe in moderate amounts. It can be poisonous if you have consumed too much of it. So its formula, or its diagram looks like this, C2H6. Like so. And it can also be found in fuel, in gasoline, in medicine, and in plastics. And the last one is isopropyl alcohol. Often you see this as a sterilizer or disinfectant or cleaner. It has 3 C's, an O, and 8 H's. 1, 2, 3, 4, 5, 6, 7, 8. Right, so those are the 3 alcohols that you need to know. Give the differences between. So we said before that sometimes an inorganic compound can have a carbon in it. Oh no, what are you going to do? How can you tell the difference between organic and inorganic compounds then? Well, first step, an organic molecule must contain carbon. So if someone asks you, A, B, C, D, which of these is not an organic molecule, if it doesn't have carbon, it cannot be organic. So here's our carbon, here's another carbon in that guy, here's carbon. All of these molecules are organic because they contain carbon. Usually the carbon is first, but as you can see here, K2, potassium. So in this case, the C is not first, but it's still an organic molecule. Inorganic molecules that do contain carbon are found in 3 ways as carbonates. So carbonates are not living. We talked about these in class the other day. The CO3 part is what makes this calcium carbonate molecule become a carbonate. The CO3 makes it the carbonate. There's also Na2CO3, sodium carbonate. There's also inorganic molecules called carbides. These are not organic, but they do have carbon in them. You just need to get familiar to recognize what they are. And also notice here, carbonates have CO3, carbides have a C at the end. Or there are oxides. So oxides will often contain carbon as well, like carbon monoxide or carbon dioxide, but these are not living, are not found in living things, like to make it living. So we do not consider these to be organic. Most inorganic molecules will not contain carbons. So here we have iron 2 chloride, we have ammonium sulfite, and phosphorus bromide. So these are not organic compounds because they do not contain any carbon molecules. Next class, we will be looking and exploring these a lot further. Please come prepared and ready to learn.